Greetings, this is Artie from Artifact Electronics. In this episode, we'll be having a look at this Atari Missile Command arcade PCB. This came out of a full-size arcade cabinet. It was released in 1980. And in 1980, depending on your biological age, you might remember that we were still at the height of the Cold War. And this game deals with intercontinental ballistic missiles. You're the commander of 3 missile batteries trying to protect 6 cities on your screen. Hopefully later on I can actually show you what all of this looks like and go a little bit more into the operation of the game itself. But for now, this board is assumed not to work, and we will check it out. Now, there is going to be quite a bit of footwork required for us to be able to check this out, because remember, this is a motherboard. It needs a power supply. It needs a display. It needs buttons to run it. I do not have the cabinet for this. I just got the board and some of the power supply components, and we're going to run through those, set up everything to at least get to a point where we know that we're powering this board correctly, hook it up to a display, and if it doesn't work, then try to troubleshoot it. But wait, that's not all. There is also a second board here, identical, well, almost identical to the first one. Working condition unknown. And once we got the power supply chain and the display chain and everything else set up, we'll check out both of them and see if they work, and if they don't, if we can repair them. Quick overview of the board. Essentially, it's a pretty standard computer setup. It's got a 6502 processor, some ROMs here. It has DRAMs over here for screen memory. This is the Atari so-called Pokey chip that generates sound. And of course, everything is made out of discrete logic. It does have a few test points on there, which is very nice. They're labeled and easy to clip onto and try things out. And of course, first you give it a nice visual inspection, and I did that. And the only thing I could find was this cap here seems to have been broken off, which is a common occurrence on these boards, because anything protruding from it, when they get stored, people don't pack them very well, and things just get broken off. Whatever's highest gets broken off. The only other thing I can see is on this dip switch here. Switch number 8 looks like it's broken. Now, neither of those two things should prevent it from working, but let's see how we set our bench up to be able to test these. The power supply comes in 2 parts. We have the transformer block over here, and this board, which is called the AR2, Audio Regulator 2. So this regulates the voltages, and it also has 2 audio amps on it. So the game's audio is run back into this board, and the speakers are also connected to this board to generate the sound. Now this one, it's basically just a transformer. There's one bridge in there generating an unregulated 10.3 volts, but the rest of it is basically tapping off all of the transformer windings. Everything's fused. There's another fuse hiding behind the transformer, and then that is routed to the AR2. Now the AR2, when I tried this one out, it didn't work. The voltages weren't all there. And one of the only obvious thing I could see at that point was You can see the burn marks over here. There was a 10 ohm resistor, and the resistor was smoked. I measured it, and it showed something like 700 or 800 ohms. But obviously that was telling us that there was some sort of trouble in here. But the 5-volt side basically has a 5-volt regulator and then a pass transistor over here that would provide or give you 5 volts to power everything. And then there is a bunch of other voltages over here on this side that will go through and measure to make sure that everything is in order. And then after that we'll have a look at the schematics, and I'll show you what needed to be fixed on this board. So let's have a look at the voltages on this board, and we'll start from this side. And so what's coming in is a 36 volts AC that I've clipped onto, and we'll start up this guy, and that shows up as 35 volts AC, which is fine. So then let's go and have a look at the DC voltages on this side. So again, it's got these convenient test points on here that are labeled. And let's get everything in the frame. Get this out of the way. So here we have a test point labeled 22 volts DC. Shows up as 23.5. And the ripple is below 10 millivolts. Then we have the other side, which has negative 22 volts DC. That's also a mirror image of the previous voltage. And again, we check the ripple, which is also under 10 millivolts. Next, we have 12 volts DC. Ripple is good. And finally, 5 volts minus 5 volts DC. And so everything on this side looks okay. Now let's go over to the other side. The other side gets an unregulated 10.3 volts DC, which is kind of high, but the reason for it being high is there's no load on it right now, so that is completely normal. And the ripple on it is also good. And then finally to the ever important 5 volt. And that's over there, and that's holding steady too. Now the 5 volt has an adjustment on there, but we don't adjust that until we actually have a load connected to it. And then we check the 5 volts on the load rather than over here, because there might be resistance in the board-to-board connectors. But let's have a quick look at the schematic so I can show you what got fixed on the AR2. Here's a schematic of the right side of the board. We looked at the one that uses the 36 volts AC. So the 36 volts AC goes through a bridge, and basically the 22 volts, bipolar 22 volts, are tapped directly off the bridge. It then runs through a 7812 regulator to generate 12 volts DC, and through a 7905 regulator to generate minus 5 volts DC. The only thing wrong on that side was there was no 5 volts, and since we had minus 22 volts, it was simply a matter of replacing the regulator. I'm not too surprised that it blew up the regulator, because that's a pretty high voltage to put into this regulator, even though there's a limiting resistor here. But, you know, no big deal. Replaced that, and the minus 5 volts came right up. Next in line is the audio amps, which you can see two identical circuits over here. They're TDA 2002 AVs, and there's two of them mounted on the large heatsink. And we'll test those later when the game is up. And finally, the 5-volt supply. There were several things wrong with the 5-volt supply. And at first, of course, you remember seeing the burnt resistor. That was the 10 ohm resistor here, which had basically grown, was still conducting, but had a very high resistance, increased by more than a factor of 10. So I put a 10 ohm resistor back in here, and the 5 volts did not come back. So I started testing some components, and I found that this diode over here, which was a 1N4002, that diode was basically open. I replaced that diode, and then 5 volts came back. Now remember, I told you that the voltages seemed a bit high and there was no load. I didn't really want to hook it up to the actual Missile Command board. The Missile Command board measured about 600 ohms from 5 volts to ground. So I took a several watt, 5 watt 1K resistor, and tied it across 5 volts and ground, and the 5 volts promptly dropped to 2.2 volts. So obviously with a load it wouldn't work. My first suspicion was the pass transistor over here, which is the transistor, the large transistor marked located right in the middle of the power supply. And as I pulled it out, measured it, and it measured bad. So I remembered the I removed or replaced the 2N3055 and turned it back on. 5 volts was up, and with a 1K resistor across the outputs, the 5 volts held. So at this point, we have the power supply chain for this test ready. Here's a pass transistor that got replaced, the 10 ohm resistor, of course, and the diode over here, and the negative 5 volt regulator is right over here. So now that worked out. Actually, the most work went into building these quick and dirty harnesses. I didn't have any harnesses whatsoever, but I did have some of the plugs. So that probably took the most time. And during building those, I actually blew a few fuses because I had miswired things. And maybe I even killed something on this board while I was building the harness. So I don't know if this, I know for sure that this resistor had burned prior to my building the harnesses. But anything after that, I don't know. Maybe I did it. Doesn't matter. It now works. And of course, the most important harness here is the edge connector for the game itself, which is right here. So let's go ahead and hook up the game board. So I haven't fully addressed the display issue yet, but what came to my help was this board actually has a black and white video output. So to do this quick and dirty, I wired this to the composite video input on this, and just for a quick check to see if it's going to work. So here goes the power. And nothing happens. Now if we look at the board, the power LED is lit. there's nothing on the screen. So let's measure some voltages here. See if everything is actually getting to the board. And we will hook up to ground. Right in the middle of the board. And then go look at the voltages that we expect. And there's a 5 volts over here. That's good. There is a, let's see, there's a 12 volts over here. And the minus 5 volt, no. That is there. Hitting the reset button, nothing happens. So, looking at the board again, I think we need to figure out, well, let's start from the beginning. Let's see if the clock is running. So we have a 10 megahertz output here. This is a 10 mega crystal. And what else can we measure here? Oh, there's a 5 megahertz test point here too. So let's do that. And I've set up the scope. And what I'm going to do is, while it warms up, clip it to ground and to the 10 megahertz signal. Power is on. The clock isn't working. And that's a pretty Oh, you're kidding me. Remember this cap? Look at the crystal. One of the legs is broken off. All right. Found something wrong. That's a 10 meg crystal, so let me go and find a 10 meg crystal and replace that. Alright, I replaced the crystal. Unfortunately, I didn't have a new one, it was a used one, so there's a certain degree of uncertainty here. But yes, the old one, as you can see, has one lead sticking out and the other one was clean broken off. So let's have a look at the scope. We're still hooked up to the 10 megahertz signal here. And we shall see. Power is on. So we're getting some sort of a signal, and we can sit here and count scales and all of that, but you know, having a modern digital scope, it's an analog mode now, we will have it measure the frequency for us. We'll switch to digital, and looking at the top of the screen there, looks like we're good. We are getting 10 10 hertz out of 10 megahertz out of that signal. And there's also a tap for 5 megahertz. Let's see how that is. That's also good. So we are getting a clock now. So now let's see what the TV screen has to say. So first we turn this guy on, let him warm up, so the excitement all comes at once. And alright, the screen's warmed up, and here's power, and there's Missile Command. So it seems to be running. It's in demo mode now. There's no sound because there is no sound in demo mode on this. I'm going to have to play around with the wires to actually get a game started and all of that. But of course the problem is this is a pretty crappy demo of the game on a little black and white monitor, so something needs to be done about this. Now the problem here is as follows. When you're using an analog TV, the horizontal and vertical frequencies are generated by whatever's driving it. And unless you exceed the specs of the TV, it'll pretty much use whatever horizontal frequency you're giving it. Now I tried to use, I have a LCD TV, I have some older monitors, Dell monitors, and so what I did was I went in and I built a board, you can see over here, that essentially takes all of the video signals coming from the Missile Command board, which are red, green, and blue, ground, horizontal sync, and vertical sync, and wired those to a standard VGA plug. I then plugged the VGA plug into my collection of TVs and monitors, and there were there were different results, but none of them worked. I mean, the TV basically showed me a rug pattern, so it didn't even deign to tell me that it couldn't deal with that horizontal frequency. It just showed garbage. Some of the Dell monitors just stayed black. Then I had another really small Dell monitor, and that one actually came up and said, I cannot deal with the horizontal frequency you're giving me. At least it was honest. But with all that said and done, I needed to go on a quest to find a digital monitor that could sync to the 15 odd kilohertz horizontal frequency that a low resolution display, which is what Missile Command needs, can be shown. So I had to go on a quest for a low-res raster monitor. Of course, the most obvious choice is getting a CRT, which is what these things used, but CRTs have kind of gone the way of the incandescent light bulb, and unlike light bulbs, if you do find a CRT, people want an arm and a leg for it, so then of course the other option was, let's get a modern, or not a modern, but an LCD monitor that could handle the low-res display that this generates. And I searched on the internet, but the problem was I got a whole bunch of hits. Of course, everybody had found a monitor that works just perfectly, but you know, the ones I looked at were only sold in Burkina Faso for a year or whatever. It wasn't something that I was going to be able to lay my hands on. Trivia question, without looking this up: what was Burkina Faso called before 1984? don't put it in the comments, but don't look it up on the internet either. See if you know it already. But anyway, so that internet search didn't work for me, so I went to a couple of the local haunts that I go to see junk stores, electronic stores, and I ended up at another place, which was the local university surplus, and they had a lot of monitors. Now, one thing that I learned was that a lot of modern monitors cannot sync to low res. Like I told you before, the ones I have cannot sync to low res, and that's just the way it is. And especially lately, since everything is a 16:9 aspect ratio, usually it's a dead giveaway when you find something with a 16:9 aspect ratio that it's too modern and they just figured it's not worth supporting low res anymore. So one thing that I figured out was I got to look for a 4:3 aspect ratio, because those are older and I'd have a better chance of finding something. Anyway, at the aforementioned surplus place, I found something like this. It was a 4:3, and I did an internet search on it, and I ended up on a discussion group that basically said, yeah, these things work with Atari computers. And Atari computers are low or medium res, but the point is that the horizontal frequency of 15 odd kilohertz was supported by those monitors. So that was, I thought, great. The monitor was on a shelf, it was plugged into a VGA signal, a computer signal, a high-res computer signal, probably 1024 by 768. Looked pretty nice, but I turned it off to take it to the front desk, and I noticed some really deep gouges in the display itself, in the panel. And that's because I also saw I saw the way they were treating this stuff. I mean, the stuff that had newly come in was basically stacked on the floor on top of each other with no padding in between, and I bet you they gouged all of these things when it came to the surplus place. But anyway, those gouges were so deep I was expecting liquid to come out of the screen, so I looked around a little bit more, and I got lucky. I found this guy. Same thing, it's an NEC Multisync LCD 1970VX. And it had been sitting there for a while, so it was really cheap. And that didn't really surprise me. I mean, if you have a choice between a 16:9 aspect ratio and a 4:3 aspect ratio, which one are you going to buy? Anyway, so this was kind of orphan sitting there, but I picked it up. It was cheap, and I took it, and I brought it home. Now, one thing it did was when I brought it home, basically the stand fell out, and along with a bunch of parts, and so I spent some time first putting the stand back together again, and of course the stand decided to collapse on me in the most inopportune moment, and take a chunk out of my finger here. I won't show you my finger, but I'll show you the bandaged finger. So that was kind of an interesting start, but I finally managed to put the stand back together again, and I just plugged the VGA cable, the converter cable that I built, into the back of it. And just to remind you, there's the board. I mean, it's not really a board, it's basically a barrier strip that has all of the signals on it and then goes to a VGA connector that I hacked up. But here you go. I'm going to turn it on. That's the board. Now I need to turn on the monitor too. And there you go. There is Missile Command in full color glory. And again, as I said, there is no sound in the demo mode. I mean, the only time you hear sound is when you start a game. But we'll leave that to the second Missile Command board that is still waiting here, waiting to be checked out and tested. So let's take this number 1 board off and put in the number 2 board and see what that has to say. Here's board number 2. Just plugged in the edge connector on it, and let's see, what else do I need to plug in? Nothing. I'll turn it on, and this is what I get. Reset doesn't do anything, it doesn't run nothing at all, so I guess we're going to have to go back, and I'm going to repeat the same test I did before. I'm going to check the clock, check the voltages on the board, and see if that reveals anything. All of the tests checked out fine. I started going on and checking address and data and control lines on the processor. There was activity on it. I then suspected the ROMs over here. So what I did was I took the ROMs from the original board, from number 1, and swapped them all out into the number 2 board, because that is usually a common problem with these older boards. But this board still didn't work, yet the number 1 board worked with the ROMs off of this. So that was eliminated too. So I went back and started observing again and looking and doing a visual inspection of it. And I found 2 repairs. Looking on the other side, you could see they were resoldered, but then I looked at this side and you could easily see that these 2 guys were socketed. And if you look at the same thing on this board, you'll see that neither of those chips is socketed. Now, I salute all operators. They gave us video games and put them in all sorts of interesting places, but they're usually in a rush when they repair things. So whenever I see a field repair, well, I don't know if this was a field repair or given back, but whenever I see a repair, I closely scrutinize it. This chip is marked with an Atari logo on it. It's a special chip, but it has the exact same number as the one on board number 1. And if that's dead, then there's not a whole lot I can do. But what I then found was this chip over here, which it's a 74LS138. And I took it out, or at least tried to take it out, and I noticed that this chip had obviously been removed from a board, because if you look at this closely, you'll see that the pins are really short. And if I look at it closely, which usually means that this was mounted on another board, and after it's mounted and soldered in, they cut the pins, but somebody had removed this from another board, socketed this, and then put that into the socket, and I wondered, could that be a problem, that they put a bad chip in there? I didn't have an easy way to test that, so I started looking through the schematics to look at what signals to expect from this guy, and lo and behold, I found the problem. As I said, this is a 74LS138, but the schematic clearly showed a 74LS139 in this spot. So I went to my supply of TTL chips and got a 139. So that's in there now. So let's see if that makes any difference. By the way, one really cool thing about LCD monitors is notice this massive transformer right next to it. You put a transformer like this next to a CRT and you're going to see some really weird distortions on it. But this just laughs at it. But anyway, here's power. And there's Missile Command. So I was getting ready to do some more probing on that chip, but when they replaced it, they put the wrong chip in there. I mean, they probably went through the hassle of desoldering it from another board and putting it in and figuring, it's one digit difference, you know, it's an 8 instead of a 9. These things aren't that exact anyway. Let's put that one in. Anyway, the 138 is a 3-line to 8 output multiplexer, and the 139 is a dual 2-line to 4 output multiplexer. So yes, the chips are completely different. But anyway, so this board works now, and let's go ahead and start simulating some gameplay on this. So let's hook up some sound too. Now, probably remember that the AR2 actually has 2 amplifiers on it for the sound, but that means I have to strip more wires here and to run the sound back to the AR2, and I'm not going to do that. I'm going to use my high precision audio monitoring system here and clip that to the audio outputs. And let's see, that will need some power. And let's turn on the game. And it's still working. So now what I'm going to do is to simulate switch operation. Switches are all basically pulled high, and they get activated by grounding them. So I'm going to clip to ground and search out the coin left. So that should coin it up. It didn't make any noise, but it's telling me on the screen that I have 6 credits now. And then we just short to one of the start buttons. And let's see. I do need a trackball to play this, and that can't simply be simulated by switch closures. So we'll just let the game take its course, and happy to go ahead and destroy. So as you can see, there's 4 cities left and 3 of my missile silos. But you know, since I can't defend myself, it's just going to blow up everything. So all my silos are gone. There's 1 city left over here, and yep, the center one's making a beeline. Oh no. Boom. There's the last city gone. And the end, rather ominous. So the interesting thing on this game is there is no end to this game. If you're able to fend off a phase of missiles, it just goes to the next level, and it starts all over again. And as you're advancing in levels, it becomes more and more difficult as things go on. So what you're trying to do is basically play this game as long as you can. And I think the record for this thing is 10 or 20 million points. for somebody who played tens of hours. There's no pause here, so you got to play it all at once. And from the score, from the auto score that I got, you can see that it's pretty difficult to get millions of points on this. But that's basically it. For me now, I have a cheap solution for an arcade monitor, and the little board here, I should be able to hook up all sorts of other boards, both Atari and other manufacturers, that have RGB and the two sync outputs on them. And let's see what comes up next. But we got two boards repaired. Now I have a friend who actually has a cabinet, it has a Missile Command cabinet. So what I'm going to do is take these two boards over to his place and stick them in the cabinet and see what it looks like in its native habitat, and if things work correctly, and of course if you can play it correctly with the trackballs and that sort of stuff. Well, all good things must end. So we got 2 out of 2. But to me the most exciting part is finally having found a solution for the monitor. And now I know what kind of monitor to look for, and so do you. These generally come pretty cheaply. And as you can see, they work very well in low res. Now, one other thing I didn't show you is there's also a test. Well, there's two things here. There's a slam switch I can close, and that will sound the alarm and make the attendant come and kick you out of the place. But the other one is the self-test. So it's actually testing itself, and there you go. And it also shows you what all your options are. So if you change the dip switches, it actually updates something, even though that was the same thing. 2 plays, 1 coin 2 plays, and so on. You can also change the language for it and all that good stuff. So yeah, the next time I hope you picked up some pointers on how to get these kind of things fixed. So when you come across a Missile Command next time that doesn't work and is really cheap, you won't hesitate to pick it up. These things are eminently fixable. I do see damage on them a lot of times that you can see. Another thing that happens is that the edge connector over here usually gets damaged. This is ground and 5 volts over here, and the edge fingers tend to come off or burn off and either need to be replaced, or you just directly wire the power to the board directly. And but you know, it's either that or there's stupid errors like the wrong chip inserted, or something that protrudes from the board being broken off. And the very first thing you should check is always for the crystal, because I can't tell you how many arcade boards I've seen where the crystal sticks straight out and gets broken off. I don't know why they just started making the room on the board and laying the crystals flat on the board so that wouldn't happen. But who cares? They sold a gazillion of these things, and if it broke, it broke. Then people just came and bought a new one, right? But anyway, let's see, what are the last words? Oh, don't forget thumbs up and to subscribe and all that good stuff. And most important of all, keep it real.